Hello friends, today also we are going to start with a quote. It says, always take in mind that as the area of light increases, the perimeter of darkness also increases. Okay, let's get started. For today's, the topic is scale in Scalene. So I have named this topic because it's all about measuring the lengths of line segments and finding the area of scalene triangle. So the main objectives will be to make the students able to use the formula to find the area of scalene triangle, and the main purpose of this video is to involve the students kinesthetically. So things that students should know beforehand will be to use a ruler to measure the length and some simple arithmetic calculations. So for this we need the materials like cardboard paper, some thumb pins, a rope and a scale to measure distance. So at first we draw a triangle in a cardboard paper, then we put the thumb pins at the corners of the triangle. Then we take a rope and wind it for 2 times. So you can start winding this from here, wind it like this for 1 time and again go for the next time. Then the next step, we unwind the rope and we get a long rope like this. Then we cut the rope into half like this. With a scissor, and then it gets divided into 2 parts. We again divide this rope into half like this. So hence there will be 4 small pieces like this. So in the next step we are going to put all these ropes in these line segments like this. So we go on continuing this process. So among the 4 pieces, the 3 pieces are used in the triangle like this and 1 piece is left over. Then what we do is we cut the pieces that are left unused. For example, this piece is not used in making the triangle, and this piece and this piece. So we cut these pieces out with a scissor. Then just to remember, these 3 trees are on the 3 corners of the triangle. Let's move the trees out there like this. Now the bottom part of the tree is called root, so a root sign is given over here, and the roots are elongated like this for all these 3 trees, and a symbol is given here which symbolizes a multiplication sign over here. Now what we do is we have got these 4 pieces left over, so we are going to move these pieces over here. Now the main part is measuring the length of the rope. So we can use a scale to measure the length of all these ropes that are leftovers, and we also measure the length of the sides of the triangle like this. So what we can see here is that if we replace this measurement over here like 11, 6, 4 and 1 and then calculate the result, it will actually give the area of this triangle, which is almost equal to 16.25. So you may get surprised, how does it work? Let's see mathematically why does it work. So assume and the name of the triangle is triangle ABC, and the side that's opposite to angle A is small a, and the side opposite to angle B is small b, and the side opposite to angle C is small c. So let's recall what we have done. At first, we have wound the rope 2 times on the perimeter of the triangle, so we got a long length. So this is nothing but 2 times the perimeter of the triangle, since we have wound it for 2 times. And after cutting the long rope, which is 2 times the perimeter in length, then we get 2 small pieces, then which are of length, perimeter and perimeter. Then again we cut these rope into 2 small pieces. That means it will give the length of half the perimeter, which is represented by S, which means semi-perimeter. Then what we did was we moved this rope just on the sides of the triangle like this. Now it's the turn of cutting the pieces. Now, since this is a leftover piece, cutting this piece means, since this whole length is S or the semi-perimeter and this length is nothing but B, so this leftover part length will be S minus B. So we were actually cutting the piece of S minus B. Similarly, when we are cutting this, we are cutting S minus C. And for this portion also, this portion is actually the semi-perimeter S, and this portion is actually A. Hence, if we are cutting this part, then this will be S minus A. So we are actually cutting S minus A, and this part is nothing but the semi-perimeter itself. So what we did was we brought these pieces over here like this, and we have already known these pieces are nothing but this piece is S minus A, this is S, this is S minus B, and this is S minus C. And according to the area of scalene triangle, we know that the area of triangle is given by square root of S times S minus A times S minus B times S minus C. So it is how it works. The main purpose of this video is to make the students involved kinesthetically, so that they can easily remember this activity of doing it, and hence can remember this formula as a result. They can easily visualize the things that they do rather than the formula they use. So thanks for watching and keep inspiring students.